I thank you all for watching my videos. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. Let us now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of June 2023. This is from Linear Algebra and the problem is related to the inner product. This question is from the part B, which is a multiple choice question. It carries 3 marks. The question ID is 704031 and this question is suitable for all these examinations. Right, the given question is let x is equal to the n tuple x1, x2, xn and y is equal to the n tuple y1, y2, yn denote the vectors in R power n for a fixed n greater than or equal to 2. Which of the following defines an inner product on R power n? We are given 4 options. So these are the 4 options given to you and we will be talking about these options in detail, the validity of them, whether they define inner product or not, in detail in the subsequent slides. We recall what is an inner product. We have V, a vector space, over a field F of real numbers or complex numbers. A map that assigns for each ordered pair u comma v in V, that means the ordered pair is in bracket ordered pair u comma v coming from v cross v, and there is a map that assigns for each ordered pair of vectors u comma v in V a scalar from f, that it is a function from v cross v to f, written as this element of f is written as u comma v bracket u comma v and is called the inner product. It is called the inner product if it satisfies the following properties. And first property, IP1, inner product property 1. Ordered pair that the inner product u comma v is equal to bracket v comma u bar, where bar denotes the complex conjugate for all u v belongs to v. And if we are working with the field of real numbers, then the bar will not be there and u comma v is equal to v comma u in that case, and it is called symmetry property. IP2, and this is the inner product of alpha u comma v is equal to alpha times the inner product u comma v for all u v belongs to v, for all alpha belongs to f. This is called homogeneity. IP3, the additivity, the inner product u plus v comma w is equal to the bracket u comma w plus the bracket v comma w for all u v w belongs to v. This is additivity. And IP2 and IP3 put together is called the linearity in the first slot. Right. IP4, we have the positivity. It is called the bracket v comma v is greater than or equal to 0 for all v belongs to v. And IP5 is the positive definiteness of the inner product, that is the bracket v comma v is equal to 0 if and only if v is equal to 0. IP4 says positivity, IP5 says positive definiteness. If these 5 properties are satisfied, then it is called inner product. Right. Let's now discuss the solution of the problem in detail. We have r power n, n greater than or equal to 2, and x is a n tuple, y is a n tuple coming from r power n. And we verify the conditions of the inner product for n is equal to 2 for the options given in 1, 2, 3, 4. Right. And why we have chosen n is equal to 2? Why not any general n? Because it will be convenient for us, and it will be tedious to write down the n tuples, and the discussion will be lengthier. Right. Now then x will be the ordered pair x1 comma x2, y is the ordered pair y1 comma y2 belongs to R square. Let's call the first option. So the bracket x comma y is equal to sigma I comma j starting from 1 to n of xi yj. Right. So first let us see what is this one. So this is I is sigma I is equal to 1 to n. Let the j run first. So xi into y1 plus y2. Now let the I run now. So I is equal to 1 to n. So this will be x1 into y1 plus y2 plus I is equal to 2 x2 y1 plus y2. So expanding, you will get x1 y1 plus x1 y2 plus x2 y1 plus x2 y2. Now is it an inner product? Does it satisfy all the 5 properties? So first normally we verify for the positivity and positive definiteness. If they are satisfied, then only we will verify the other conditions. So the bracket x comma x will give you, that means for y we are writing x, for y1 we will write x1, for y2 we will write x2. Right. So x comma x will be equal to x1 square plus x1 x2 plus x2 x1 plus x2 square, and that is equal to x1 plus x2 whole square. x1 x2 plus x2 x1 is 2x1 x2. So that will be x1 plus x2 whole square, which is a perfect square. So this will be greater than or equal to 0. This is sums of squares. Sums of squares always gives you greater than or equal to 0 for all x belongs to R square. So now let x is equal to the ordered pair 1 comma minus 1. 1 comma minus 1. So now then the bracket x comma x will be equal to, for x1 1, for x2 minus 1 we write down. So 1 in this we write down 1 minus 1 whole square, that's equal to 0. So x comma x is 0, but x is not 0. It is 1 comma minus 1. It is not 0. So which property is failed? The positive definiteness is not satisfied. The positive definiteness is not satisfied. That is IP5 is not satisfied. Therefore, the option 1 does not define an inner product. Right. Let's move to the next option. Option 2, x comma y is equal to summation I comma j is equal to 1 to n xi square plus yj square. So x comma y is equal to sigma ij 1 to 2 xi square yj square. The moment people see xi square yj square, so the linearity will not come. So therefore this is not an inner product. But how I will show you. So you expand this, you get this one. And that is equal to 2 times x1 square plus x2 square plus y1 square plus y2 square. Now look at x comma x. X comma x will be equal to 4 times, because y1 is equal to x1, y2 is equal to x2. So you will get 4 times x1 square plus x2 square, which is greater than or equal to 0 for all x belongs to R square. Positivity has come. But now the positive definiteness is x comma x is 0 will imply 4 times of x1 square, 4 times in brackets x1 square plus x2 square is 0. This will imply x1 is 0, x2 is equal to 0. That will imply x is implied by x is equal to 0. So the positive definiteness is also satisfied. So let's look at the linearity. So in that, first we talk about the homogeneity. Bracket alpha x comma y is equal to 2 times in this, for alpha square x1 square, for this alpha 2 x2 square plus y1 square plus y2 square. Agreed. Now assume that the homogeneity is satisfied. That is, bracket alpha x comma y is equal to alpha times bracket x comma y. Let's say. So that will imply alpha x comma y is 2 times alpha square x1 square plus alpha 2 x2 square plus y1 square plus y2 square is equal to alpha times bracket x comma y. Bracket x comma y is 2 times x1 square plus x2 square plus y1 square plus y2 square. Agreed. Now let alpha is equal to minus 1. We take a alpha is minus 1 and x not equal to 0, that is x1 comma x2 not equal to 0 comma 0, and y is equal to 0, that is y1 is equal to 0, y2 is equal to 0. Then the above equation becomes 2 times alpha square means minus 1 square. So x1 square plus x2 square 2 times is equal to alpha is minus 1 into 2 times x1 square plus x2 square, because y1 y2 are 0. And where you see x not equal to 0, y is equal to 0. So from this we will conclude x is equal to 0. How? Because you see 2 times of x1 square plus x2 square is equal to minus 1 2 times 2 times x1 square plus x2 square. So this will be 4 times x1 square plus x2 square. This will imply x1 is 0, x2 is 0. Because 4 times x1 square plus x2 square is 0. So x1 square plus x2 square is 0. This is if and only if x1 is equal to 0, x2 is equal to 0, therefore x is equal to 0. This is a contradiction because we have assumed we have x not equal to 0. This is a contradiction to this. Therefore, linearity is not satisfied. Therefore, it does not define. So that means the linearity condition is not satisfied. Therefore, the option 2 does not satisfy, does not define an inner product. Right. We move on to the next option. We talk about option 4. This is the inner product given and we take n is equal to 2. So then ordered pair x comma y is equal to sigma j is equal to 1 to 2 xj y n minus j plus 1. That is equal to sigma j is equal to 1 to 2 xj, n is 2 plus 1 3 minus j, and let j run, it will be x1 y2 plus x2 y1. Agreed. So now the ordered pair x comma x is equal to x1 x2 plus x2 x1, that is 2 x1 x2. Now let x is equal to 1 comma 0. If you substitute, so then it will be x comma x is equal to 2 times x1 is 1, x2 is 0, so it is 0. So x comma x is 0, but x is 1 comma 0, which is not equal to 0 comma 0. So there's the positive definiteness is not satisfied. It is not satisfied. So therefore option 4 does not define an inner product. So what is left? The left out is option 3. So obviously that should be true. Your answer is option 3. Anyway, I will show you how this option 3 is true. Option 3. Ordered pair x comma y is equal to sigma j is equal to 1 to n j cube into xj yj. Now take n is equal to 2. Then you will get x1 y1 plus 8 times x2 y2. J is equal to 2. When you take j is equal to 2, j cube is 2 cube. 2 cube is 8 x2 y2. Agreed. So as usual, we see the positivity. X comma x is x1 square plus x2, 8 times x2 square is always greater than or equal to 0 because it is sum of squares for all x belongs to R square. Positivity IP4 is satisfied, and positive definiteness x comma x is equal to 0 will imply x1 square plus 8x2 square is equal to 0 if and only if x is equal to 0. Thus IP5 positive definiteness is also satisfied. We move on to IP1. X comma y is x1 y1 plus 8 times x2 y2, which is same as y1 x1 plus 8 times y2 x2 because of commutativity, because these are all real numbers. It is the bracket of y comma x. So that's x comma y is equal to y comma x. It is symmetry property, and we are in R square. We are in R squared. Our field is field of real numbers. Therefore, the bar will not be there. Conjugate will not be there, and it will be x comma y is equal to y comma x, which is symmetry. Symmetry property is also satisfied. Move on to IP2 and IP3. They are put together as linearity. So let us test for alpha x comma y comma z. That is equal to, if you use the definition, alpha x1 plus y1 multiplied by z1 plus 8 times alpha x2 plus y2 into z2. Now expand. So this is to take the alpha common, alpha times x1 z1 plus 8 x2 z2 plus y1 z1 plus 8 y2 z2. And this, what is this? This is alpha times x comma z plus this is y comma z. So for all x, y, z belongs to R and alpha belongs to R. Thus, linearity condition is also satisfied. So IP1, IP2, IP3, IP4, IP5, all the 5 conditions of the inner product is satisfied. Thus, this defines an inner product. So option 3 defines an inner product, and our answer to this question is option 3. And that is the detailed discussion of the solution of the given problem. Right. It will take a little bit of time, but otherwise it is an easy question. I am sure that you have understood the solution of this problem. Thank you for watching this video. Now, please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of Learning. I wish you all the best. Thank you.